16. This is going to be our second day for elimination. Yesterday, we added and subtracted the equations. Now, today, we're going to say, hey, I've got two equations, linear equations, in standard form, and none of them will eliminate if I add or subtract the variable, so we're going to have to manipulate it another way. So, let's jump right in. Let's start with what we finished with yesterday, okay? On the family outing, Tyler bought 5 cups of the cocoa. He bought the 4 pretzels. Then he went back and he bought more cups of cocoa, more pretzels. Here's the equations, and it says, what does the solution to the system represent in this situation? Okay, the solution, guys, remember, is I'm finding C and I'm finding P, so it would be the price of cocoa, okay, and the price of pretzels. That would be the solution to my system. Now, we have these. If you notice, if one of them would have eliminated, we could have found cocoa and then plugged it back in to do that. But we see here, okay, he added both of them to get an 8p instead of subtracting. So now I have this new equation. Okay, explain how the same pair, the solution to the two original equations, is also a solution to the new equation. It's because we still added together, okay, so we're still adding, and then again, remember the big term is equivalent expressions to both sides. That's why we've been doing this over the course of these last 2 weeks, what's equivalent expressions and so forth, and that is why. Does that help us solve the original system? Whereas they could be used, if you plugged in the C and P that you'd find, it would still give you that answer? Absolutely not. Okay, it doesn't help us because none of the variables were eliminated. Okay, that's why. All right, let's go on to the next one. All right, so consider the equation x plus 5 equals 11. What's the solution? So if I come over here, guys, x plus 5 equals 11. We do know that if I subtract 5, because that's the inverse operation, I'm still just with x equals 6. Okay, so we know that. Boom, correct. Fire emoji. Now, what if we multiply both sides of the equation by a factor? They say 4. What equation would we have? Here's what I have. And we're going to multiply this left side by 4. Well, we know that I can't just add it to the 4. I've got to use distributive property. So I'm going to have 4x plus 20 equals, okay? And remember, and I forgot to put it down, we do it to both sides. What you do to one side, you do to the other. So now it's going to be 11 times 4, and I get 44. Okay, so I do have 4x plus 20 equals 44. So now let's see, guys, if the solution, what is the solution to the equation? Well, we've got to move the 20 over. 4x equals 24. Divide by 4 to isolate the variable. And x is going to equal, let's see, 6. Still the same, okay? It's still the same. What if we multiplied both sides by 100? All right, save some times. You do that. Guess what your answer is going to be? 6. 6, okay? Why does that work? We go back here, okay? Why did 4 work when I plugged the 4 in? Why would 100 work if I do that? Again, if you do it on one side of the equation and you do it on the other side of the equation, you're still going to be left with equivalent expressions. You're not changing the variable, you're just changing the constraints to both sides. However, you're doing it equally to both sides. Equivalent expressions always equal each other, no matter what you do to them. Okay? So, consider these two equations in a system. What is the solution? Well, we know that I click here, the solution's where they intersect, and it's -1, 5. Correct. All right. Now, let's do this, and it says, let's write a couple equivalent expressions by multiplying both sides by the same number. So, okay, guys, if I had 4x plus y equals 1, and they say, for example, a 2, what happens if I take a 2 here, and I take a 2 here. Well, I'm going to use distributive property. I'm going to have 8x plus 2y equals 2. Okay, 8x plus 2y equals 2. Hey, we're right. It's crossing that line. Okay? Now, what if I would have added a negative 5? Ooh, a negative. How does that change us? Okay? Would a negative change us? That's a question in its own right. Would a negative change us? Well, we'll bring these over, and I got a negative 20x minus 5y equals negative 5. Negative 20x minus 5y equals negative 5. Still works, because again, guys, you're doing it to the same side of the equation. For time purposes, let's keep moving, okay? Make a couple of observations about your graph, okay? Guess what, guys? This line right here didn't change when I added or when I multiplied by 2 on both sides. And it didn't change when I multiplied by negative 5, okay? It didn't change. I'm sorry. The line didn't change. You know why? Because I'm adding to both sides. Okay? Because I'm adding to both sides. That's why, guys. Now, we look here. How can we explain the identical graphs, okay, between these two when I'm saying, hey, it's the same x value and the same y value? All right? It's because you're multiplying, or let's do this. You're manipulating both sides of the equation. Here's the key. Equally. If it's equal, we're still in equivalent expressions, okay? Equivalent expressions. What move was made to generate A1, A2, A3? Why did we create equations that are equivalent to A? Okay, now we see here, okay, you went from equation to the left to the right by multiplying by 5. Then you can see here we cut it in half, but it's still the same outcome. Why would we do that? Okay, here's the key. We're going to do that to be able to use that to eliminate a variable in a system of equations. Okay, that's why we do it. And it's going to be so awesome when you get to see it. Okay, so here's the system you solved by graphing earlier. So we look here. Okay, we had this. Now notice here, guys. What did she do? How did she get equation B to be 4/8 plus 8y equals 36? Look at this. She took x and multiplied it by 4. She took the 2 and multiplied it by 4 to get 8 by 4. So she multiplied equation B by 4. And hey, if this is confusing, guys, right now, I promise, once we dive in and we do some examples, you're going to feel pretty good, okay? And then you see here, okay, now, guys, when she had these, hey, y and 8y don't give me negative 7. Here's what she did. Then she subtracted, right? She subtracted equation here. We'll capitalize it. Equation B from A. Okay. What might be the possible reasons for these moves? Again, guys, the whole name of the game is to eliminate a variable. Okay. Again, hey, if I'm going too fast, pause, rewind, go back. I'm sorry, but we're going to do a little how you doing, keep it moving here. And so that way, if you are struggling, if I'm talking too fast for you, just pause it, collect your thoughts, move forward, or you can rewind. Okay, so complete the process or complete the solving process algebraically. What's the solution? So guys, I'm going to start back. Let's go back to the very original right here. And here's where I'm going to differ from, I think her name was Elena. This is how I'm going to differ from Elena. I want these to cancel out. Now let's stick with it and let's choose the x's for Elena to cancel out, all right? So now, guys, I'm going to multiply what times 1 to get me a 4? Well, it's easy, 4, right? Now, I want those to cancel out. So how about instead of multiplying by a 4, let's multiply by a negative 4. So we did not change equation 1, but we are changing equation 2. So now I'm going to use distributive property all through that. So I'm going to take negative 4 times x, and that gives me negative 4x. Negative 4 times 2y, that's going to give me a negative 8y. Negative 4 times 9, that's going to give me a 36. Negative. About screwed up there, I'm sorry. Okay. So now, y'all, when these cancel out, we get here, we're still at the negative 7y and the negative 35y that she did, but hey, the only difference between me and Elena is we multiplied that negative already in. Divide by negative 7. Y is going to give me 5. Now I can plug it into any equation, okay? I'm going to say for time purposes, let's plug it in just to the top one. So I'm going to have 4x plus a 5 equals 1. Move your 5 over. Now I've got 4x equals a negative 4 divided by 4. And negative 4 divided by 4 is a negative 1. Okay, so I've got my x, I got my y. Answer should be in as an ordered pair. So I do have negative 1 comma 5. Correct. Okay, let's go to slide 11. Suppose we want to solve the system by first eliminating the y value. Okay, hey guys, what factors should we use? For me, and we'll go ahead and write this down, x plus 2y equals 9. Even if we don't have to, it's good to use this. Good to use paper and pencil. If you're not using it, pause the video right now. Go get paper and pencil. Now we want these y's to cancel out, guys. For me, I'm going to multiply by a 2. Hey, they say 2. I'm going to say a negative 2. But if we want to do what they're doing, we'll multiply by a 2. That's okay. We'll multiply by a 2. Okay. Elena didn't use the original 2 equations to solve. Instead, we multiplied each side of the b equation by 4 to get equation b1. All right, how do we know it's the same pair? Hey, guys, if we know it's the same pair, okay, you're still going to get the same variable to eliminate. But let's stop this jazz for a second. We can do all this what ifs, what that, everything. Hey, let's multiply by the 2. Let's cancel the y's, and let's just solve it how they asked us to do it from slide 11. Okay, so I look here, use my distributive property, and I do get 8x plus 2y equals 2. I get an x plus 2y equals 9. It was unchanged. Now, my signs are the same. They're not going to eliminate. So let's subtract the bottom equation. And I'm left with, what am I left with? A 7. Cancel. 7x equals negative 7. Divide. Divide. X is still negative 1. Plug that into an original equation. I'm going to choose the bottom equation. So negative 1 plus 2y equals 9. Add 1. 2y equals 10. Divide by 2. Y equals 5. So even though now we chose to eliminate the y value, hey, I'm still getting negative 1, 5. Okay? So you can kind of get a little bit of whatever you want to do there, a little bit of choice in which one you want to eliminate first. But still, since we're multiplying both sides, it's equivalent equations. Equivalent expressions. Still get the same answer. Okay? So, with, again, hey, I'm not concerned about these things, with Elena and all that stuff there. How about this? Okay, let's look at our first equation. 4/5 x plus 6y equals 15. The next equation is negative x plus 18y equals 11. Now, she got a 4 here. Okay, she got a 4. How'd she do that? Well, hey, here she had a fraction. She didn't like the fraction. So how do you get rid of that denominator? If it's a 5 in the denominator, you're going to multiply. She multiplied equation 1, and she multiplied by 5. We see that because each one was enhanced by 5. Okay, now guys, we look here. What did she do? She was at step 1 here. The next thing she did was she multiplied the bottom equation, right? She multiplied the bottom equation by 4. Sorry. Okay. Now, why would she do that? To get her x values canceled. And you know what? We are missing a grand opportunity for us to show this on paper, so that'll help us understand it as well. So I had 4x plus 30, y equals 75, negative x plus 18y equals 11. That's where we're at. These don't cancel out. So she then took the bottom equation by 4, and so now I do have 4x plus 30y equals 75. The bottom equation now is a negative 4x plus 72y equals 44. Okay, so again, guys, we see that she multiplied by 4. Correct! Flame emoji. Boom. Okay. Now, guys, we see here, what did she do? Okay, she added equation 2. Let's see. Uh-oh. Can't zoom in or out. This is all we've got. Okay, she would have added equation 2 or from equation 1, 2, or from equation 2. So basically, guys, she added down. These cancel. Okay, and what you're left with is 102y equals, bringing these together, I'm going to get a big 119. Now, right here, guys, what did she do? She divided each side of equation 2 by 102. Okay, 102. And so that means here we divided by 102. And we reduced, and what y is going to give you is 7, 6. Okay. Now, for each step, you will describe the move to get from step 4 to 5. Elena substituted 7, 6, okay, for their variable y in equation. Which one did she substitute it into? Anybody know? She substituted it into the 4x plus 30y equals 75. Okay, that was the first equation. Okay, it was the first equation because she's taking that equation that she manipulated by 5. So now, guys, we have 4x plus, and she would have had 30 times a 7 over 6 equals 75. Okay. We knew by taking that, you do get 4x plus 35 equals 75. Now, we did this, guys, and that's equivalent there. Hey, I would caution you. I mean, this is a fraction, so it's okay. But I would caution you when we plug in variables. Do not plug them into ones that you've manipulated already. Plug it into an OG equation because those haven't been touched with. So that way, in case you did screw something up from the very beginning multiplying, we would find that out. Okay, now with this, it's a fraction. It's good to put it into that so that we can kind of eliminate those fractions and deal with whole numbers. Okay, so now that we're here, guys, the next thing you're going to do is you're going to subtract each side of equation 1, all right, by 35, because if we look over here, guys, we're going to isolate the variable, and I'm going to get 4x equals 40. Okay, 35. So then we look here, guys. You're going to divide, all right, by 4. So I'm going to get x by itself. And you're going to see that x equals 10. So the equation to this, guys, is, remember, x, y is a coordinate point. So it would be 10, 7, 6. Okay, so Lynn and Priya were working on solving this system of equations. 1/3 x plus 2y equals 4. X plus y equals -3. Lynn's first move was to multiply the first equation by 3. Priya's first move is to multiply the second equation by 2. Explain why either move creates a new equation and with the same solutions as the original equation. Okay. Hey guys, because if they do that, what's going to happen is they're going to be able to subtract, and one of the variables is going to eliminate. Okay. Because when they combine, okay, through subtracting, one of the variables will eliminate. Now, whose first move would you choose to solve this equation? For me personally, and I would imagine for freshmen, you probably don't like fractions. You probably like your whole numbers. So I would probably choose what Lynn did. Okay? So, hey, before we sign off, let's take this and let's solve for it. So I've got a 1/3 x plus 2y equals 4. I've got an x plus y equals -3. Now we want one of these to cancel out. Lynn chose to multiply the x values, which I agree because it eliminates a fraction. So I look here, 1/3. What am I going to multiply 1/3 by to get a 1 so that when I subtract, they'll cancel? The reciprocal, which is 3. So I'm going to take each term by 3, and I'm going to write my new equation. So 3 times 1/3 x isn't just an x, plus 3 times 2 is 6, and 3 times 4 is 12. Now I didn't touch the bottom equation, and so here I am. Now, we want to change the sign so that they cancel, because right now they wouldn't. That becomes a negative, that becomes a negative, positive. Now my x's cancel. 6 minus 1 is 5y. 12 plus 3 is 15. Hey, we divide by 5 to isolate that variable, and yes, we did it right. It is a 3. Now you can plug this into either the top equation or the bottom equation. For me personally, I'm going to stick away from equation 1 because of the fraction. Because again, plug it into the original equation and make sure that you're plugging it into a solid equation, so to see, did I do it right from the very beginning? Okay, so now we have, I'm going to plug it into this equation right here. So what I'm going to have is I'm going to have x plus the 3 here, and that is going to give me a -3. All right, hey, next thing we do is isolate that variable, subtract the 3, and you're going to find out that x equals -6. We need to put that as an ordered pair, so that means my final answer is -6, 3. All right, there you go, guys. That is elimination day 2. Now just ain't nothing to it but to do it. Have a great day. Let me know if you got any questions.